I'm Andy Chadha, President of ARC Advisory Group. I'm delighted to have Doug McQuistion, former Executive Director of Mars Exploration Program, with us today. Welcome, Doug.
Thank you, Andy.
Doug, you delivered an amazing keynote presentation at our forum this morning, and I could tell everybody in the audience was riveted to you, and they couldn't have enough of it. And you talked about in it near the end that 7 minutes of terror. Mm-hmm. And in that room, all of the crew, the team was riveted. And I'm wondering if you could share some special moments, from those 7 minutes of terror.
Sure, I'd be happy to. It was very interesting. Probably one of the most remarkable things I found about that 7 minutes is having done the Phoenix mission in 2008, that landing. That 6 minutes of terror seemed like it took forever. It was the slowest process, just time compression, I guess. It just seemed like it just took forever to get through. This activity with MSL, because there were so many activities going on, guided entry, getting rid of the cruise stage, ballast mast, guided entry, sky crane, parachute, not in that order, obviously, landing. It went by so quickly. It was amazing. I think it was because there were so many things going on that it really went by very, very rapidly. And the team had been at this for almost a decade. And there was not just a sense of joy and excitement, but there was a sense, in a way, of relief. Not that it worked right, but that we had gotten to that culminating moment in a mission that has affected so many people's lives throughout that almost 10 years of development, that it made it a very comforting feeling to know that we were at that crescendo, if you will, and at the final. And of course, then once we landed and everything, and we were safe on the surface, just that call that we were safe on the surface, all the emotions broke out. It just came pouring out of everyone, and you've seen a lot of the YouTube videos of that experience. So it was quite emotional, quite emotional.
You talked about why landing on Mars was so different from landing on Moon or the Earth, and what you had to, obviously, you came up with this idea for guided entry, that was so crucial and different. Could you talk a little bit about that?
Sure. Well, the past couple of landings that we had done were airbags, and so we bounced to the surface with Spirit and Opportunity and Pathfinder, and a soft landing for Phoenix, which was an appropriate approach for that mission in the Arctic. But to be able to take the science to the next step, to bring the most complicated, most advanced analytical laboratories to the surface of Mars, to really understand the possibility of habitats past or present on the surface, required a machine around those instruments to allow them to function properly, to keep them alive, to provide power and thermal care, as well as to move them around the surface, which we have learned to be so crucial. It truly was the culmination of a lot of thoughts and ideas. But how to get a metric ton to the surface was the challenge. You can't do it with airbags. The airbags just won't handle that. You can't really do it well with a soft landing, because then you're carrying around propulsion tanks and propulsion systems. So some of my brilliant folks at JPL came up with the idea of the sky crane with a descent stage, and to reel the rover down on 3 bridles with an umbilical, to land it softly on the surface, and the descent stage flies away. At first, it's crazy. At first, it's just a crazy concept. But as you understand it, as you think about it more, and the logic is there, it's, as I said this morning, it's taking the engines of the Viking landers of the 70s and putting them on the top, so that you then can dispose of those and be left with just the core instrument set and life support and mobile systems that you need to take science to the next step on Mars. The first decade of Mars exploration has been following the water. Well, we followed it and we found it. And we've proved it over and over that water exists in many ways, past and in the present. So we have a water planet. But MSL, Curiosity, bridges that gap from water to the potential for life on that planet. And as we move forward with some European missions in the middle of this decade, and then another mission very similar to MSL in the 2020 timeframe, maybe we can find out if we actually have had life on that planet.
You know, we are getting some amazing pictures from Mars. You know, I call that Curiosity is the ultimate connected device
Ah, yes.
we have.
Oh, yeah.
And we will have for many more years.
We will.
Yes. Could you talk a little bit about the equipment? You know, you had all these labs and the cameras
Sure.
on Curiosity.
Well, you know, it all starts with the design and the equipment we use to design. Siemens helped us with that, with their software design tools. That then translated into the machinery required and a lot of hand construction of all these different pieces. Everything from thermal protection materials that we have to lay up by hand and put in place in tile form by hand called pica on the heat shield, to just all the electronics that had to be assembled. I'd like to come back to interconnectedness for a second, because MSL, Curiosity, is the ultimate communicator, I believe, as far as a connected system. So we have a device aboard called Electra, which is a software reprogrammable radio. First time one's ever been put on the surface of another planet. The orbiters is how the communication gets back to Earth. So the Electra on Curiosity and the Electra on the spacecraft that's orbiting connect to each other. They talk to each other to decide, you know, what the right data rates are based on the quality of the link, and then they transmit the data. And that's how the data gets either stored and forwarded or directly bent pipe back to Earth. So we have broken barriers. We've quadrupled the data volume that can be sent back by this new communications technique. So you're absolutely right. And Curiosity is certainly the ultimate in connected machines, at least off this Earth.
You know, we are wondering here, we are at industry forum, and you have perhaps any ideas? Can the industry, how can we use some of these ideas and the products that you developed for Curiosity? Any thoughts on perhaps we could use some of these innovations in industry?
I think so. I certainly believe that things like our risk management processes, which industry has embraced risk management just like NASA has, that we have things to learn from each other in that arena about how to manage risk, how to watch it, how to mitigate it, and how to accept it. That's a tough one. Some of the other things are instruments, miniaturization. So we have miniaturized a lot of the computers. We have taken field programmable gate array capabilities on single cards kind of to the next step, at least for space. And I think some of those techniques could be used in machines and automation here in industries on this Earth. I also believe that there's areas in new materials and the utility of technology advancements in new materials applications. We attempted to dry film lubricate titanium systems, and we weren't able to. So there's areas where I think industry can move forward in technologies that will benefit them and benefit us too in extreme environments.
Would you have any thoughts on what's next?
Well, it keeps getting exciting. What's next for NASA with Mars is we have a mission in 2013, launches at the end of this year in November, called MAVEN, and it's going to help us understand what happened to the atmosphere of Mars. Where did it go? When did it disappear? And we're going to, if you will, reverse engineer the atmosphere of Mars, which has to do with why the planet is no longer, you know, a wet, teeming planet, and it's a dry desert, with the water having gone underground, mainly in ice form. And then we have some partnership work with the Europeans. They have an orbiter in 16, and they have another step in rover capabilities. It's a smaller rover than Curiosity is, but they've got some really innovative instruments, and we're partnering with the Germans and the French on one of the key instruments, astrobiology instruments for them. That's what's next through this decade, and then a reflight of Curiosity with a different instrument payload in 2020. So the future is bright, the future is exciting, and the future is becoming more international, which is nice.
Very, very interesting stuff. Thank you, Doug. We have been listening to Doug McQuistion, former Executive Director of Mars Exploration Program. Thank you for watching.